PreCalc. It's Monday, and it is the 5th. So let's get started. Let me see if I can straighten up the screen a little bit. It looks crooked. Alright, I don't know if that's any better, but we'll pretend it is. So, we are looking at December the 5th. And today we're going to solve equations. Trig equations, of course. Solve equations with double angles in them. So we're going to use double angle IDs to solve equations. Alright, so I'll do 2 examples and then we'll have some pop up in class. So let's see how they work. So the first one I want you to do is solve. And I want you to solve this equation. 2 cosine x plus sine of 2x equals 0. Recall the word solve means to find all the expressions for x that will make this a true statement. So I noticed that there's a double angle, a sine of 2x, and that has been in our work lately. So someone's thought cloud. Shannon, thank you. The sine of 2x equals 2 cosine x sine x. Oh, I'll write it the way we usually write it. 2 sine x cosine x. Alright, either way is correct. Alright, so I notice that I have a sine of 2x in here, and I want to express it without the 2x. So I can rewrite it, substitute right in here, this expression from Shannon's thought cloud. So I have 2 cosine x plus, now I'm changing to 2 sine x cosine x equals 0. So that looks like something that you solved on a test not long ago, and some of you on that test were virtually error-free. So it's time to bring out those error-free skills again and solve this. When it's set equal to 0, it's important to factor it. So I see a 2 and a cosine x in this term, and a 2 and a cosine x in that term. So when I have 2 terms, the common way to factor it is factor out what's common in both. So what is left behind still equals 0, and what's left inside the factor here, the empty factor, is what would take to multiply this by to get back to here. So I took out this entire term, so I'm going to replace it with a 1, and that 1 will, when I multiply it by the factor out here, will get me back to where I started from. What will I place here so that when I multiply, I get back to that? Well, I have the 2 and the cosine x. All I need is the sine x. Alright, so I factored it. I have 2 branches, like we are used to. I set each of the branches equal to 0. Because I either have one, when you have 2 factors equal to 0, either one equals 0, the other, or both. So when I divide both sides by 0, cosine x equals 0 on this branch, and my unit circle, the cosine is the first coordinate, so that happens at pi over 2, and also at pi over 3, right? Yes, 3 pi over 2, sorry. Pi over 2 and 3 pi over 2. So I can combine those because they're 180 degrees apart from one another. I can call that pi over 2 plus pi n, and then I would get all the repetitious answers. Keep going pi away from one another, and that is an infinitude of answers from that branch. Over here, 1 plus sine x equals 0. Sine x equals minus 1. So x would equal minus 1. That's the second coordinate. So 0. It's also 3 pi over 2. So if we gave that answer here, do you see that will gather that one as well? So it's already included in this branch. So this is the entire answer right here. All right, let me show you a second one. And that one, oh, I have an eraser. Let me get something. That one we're going to use our trig IDs backwards. This time, as mathematicians, when we have trig IDs, we can use them from either side. So let me show you how to do that. And that's all for tonight. You'll be solving trig equations soon enough, and these are just sort of a taste. 4 sine x cosine x equals square root of 3. So right now, you might say, well, I'll set it equal to 0, and I'll just move the square root of 3 over to the left and set it equal to 0. But then there's nothing I can do after that that will cause either two branches to appear. There's nothing I could factor, nothing I can do to simplify it any further. So I have to come up with another strategy. So what I'm going to do is, recalling the thought cloud, we know, Shannon, may I borrow your thought cloud again? Sine of 2x is 2 sine x cosine x. Alright, so this time I notice that this almost matches this. So it would match it exactly if I would change the 4 to a 2 times 2 sine x cosine x equals the square root of 3. So I can replace 2 sine x cosine x by this expression. You'll say, well, in the last one we tried to get rid of the double angle, and this one we're putting it back in. Well, that's life. It all depends on what can get you where you're going to go. So you have to think ahead and try several things and see what works. So I'm going to divide both sides by 2 to get this 2 out of there and over here. And now you'll recall when we have a double angle inside of our expression that we look for, we can't divide that out. It's an inviolable argument. So we're going to just find where 2x equals where the sine of 2x equals square root of 3 over 2. So where does the sine of something equal the square root of 3 over 2? Second, so I think you have to go up to pi over 3. Am I right? Pi over 3. And is there another spot where something equals, the sine of something equals square root of 3 over 2? It does. It's over here, so it's 4 pi over 3. My mental unit circle is functioning today. 1/3. It isn't. It's 2/3. Okay. Alright, so check that out. So 1/3, 2/3, right. So both of those places have a second coordinate of a positive square root of 3 over 2. So now that we've taken the sign, we've looked at the unit circle, we can split this up. So I'm going to divide both sides by 2. And when I do that, this becomes pi over 6. And when I divide this one by 2, it becomes 2 pi over 6, which reduces to pi over 3. Alright, so I can come back up here and add an infinitude to pi n. So I can spin that pi over 6 around and around and get all the infinitude of answers from that. And I can do it from pi over 3. Alright, so notice that in the first problem, I took an expression that looked like this, no, the expression looked like this and made it look like this. And this second problem, I took an expression that looked like this and made it look like that. So when you solve your equations, you will have to think ahead and see what will work. All right, that's it for tonight. 2 short and sweet problems that you will bring the procedure from these, the knowledge from these with you tomorrow. Look over your comp book before class so that you can dive right in. So, till then, good night.